The problem I'd like to first talk about is found on page 308, and it's number 47. I think I did a problem almost like this in the chapter 6 video. It's been a week or two since I've done that video, so I've kind of lost track. But I probably did. It may look familiar to you. Alright, so let's read together page 308, number 47. It says, the mean number of days of work or school lost by a person to illness is 5.1 per year, according to the National Center for Health Statistics. In a small business firm with 49 employees, the mean number of days lost to illness was 7.0, with a standard deviation of 2.5 days. The firm owner wonders if the employees are sick more often than should be expected. Alright, so part A says, what is the null hypothesis the owner examines? Well, let me get the numbers up here on the board. The sample mean was, X bar was 7.0. The standard deviation, the sample standard deviation was 2.5. And the sample size was 49. So that's the pertinent details. You think, well, what about the 5.1 number the National Center for Health Statistics produced? Well, that's coming up. The null hypothesis is sort of a baseline against which we're going to see if there's something different. So let me just write it out. Now, the symbols in statistics classes, the symbol that statistics books like to use and people who teach it is H0. H with a subscript of 0. And that's the null hypothesis. Null hypothesis. Okay. And we would say it verbally as H naught. And naught is the old style word N-A-U-G-H-T. H naught is how mathematicians would normally say something like this. Null hypothesis. And by the way, we have an alternative hypothesis, H with a subscript of A. And please don't call it ha. It's, it's the alternative hypothesis. Alternative hypothesis. Okay, so what are these for this problem? Well, for our problem, the null hypothesis is that mu is equal to 5.1. Alright, now it would be easy to read this problem and think, well, okay, National Center for Health Statistics says the average in the country is 5.1. Isn't that a population mean? Well, it probably is. Okay, but, and yes, we do use the Greek letter mu for population means, but it's being used in a different context here. In hypothesis testing, mu, the Greek letter, is representing a standard for comparison. So what we're doing is we're comparing this company's number of sick days, 7.0, with the national standard of 5.1. And let me write this in plain English. So mu, and by the way, mu would stand for the population mean for the company. So in plain English, this would say that the mean number of days lost for the company is 5.1. Alright, and perhaps I should say the population mean. Let me just throw that in there. The population mean, there we go. I didn't want to erase that and recopy it. The population mean, there we go. Population mean number of days lost in the company is 5.1. Now, if you really read this and pick it apart, you say, well, but wait a minute, doesn't it say that this company has 49 employees? Isn't that the population mean for the company, 7.0? Well, it is for that year. It is for that year. But we're going to make this kind of leap and assumption and say, well, this represents the company in any year. And we've taken 1 year of 49 employees as our sample. And but we're assuming that these conditions exist continually, and so this is going to represent any year. All right, hope that made sense. So, null hypothesis says then that the population mean days number lost for the company is 5.1. Now, what's the alternative hypothesis? Well, the sample showed that they lost more than 5.1 days. So it turns out that, okay, well then that's what's going to be our alternative hypothesis, is that mu is going to be greater than 5.1. So in plain English, the population mean number of days lost is more than 5.1. Now notice I didn't say that equals to 7.0. The sample shows 7.0. I'm not trying to show that the mean number of days lost due to sickness in this company is 7.0. I'm not trying to show that at all. What we're looking for is there enough evidence here? Is this enough statistical evidence to show that the population mean for the company, not just this year but other years forward, is actually greater than the national average of 5.1. Okay, so we're not trying to estimate mu in this case. In chapter 6, we could do a confidence interval on this and try to estimate what it is. But here we're comparing. We're making a comparison of the sample mean with some kind of standard that we've chosen, a number of special interest. In this case, the national average put out by the whatever that was, that government agency. All right, now I said we would tie these ideas to our criminal trial system in the United States. Well, the null hypothesis works like innocence. Okay, we are innocent until proven guilty. All right. So remember the criminal trial. The burden of proof is on the prosecutor, who's trying to prove that the defendant committed a crime. What's the first thing they do in a criminal trial? Well, to my knowledge, the ordinary first thing they do is to prove that a crime was committed. If they don't prove that a crime was committed, then what's the point of having the trial? So the prosecutor leads off, introduces evidence that a crime was committed, and then begins to link the crime to the defendant through evidence. Often it's a chain of evidence called circumstantial evidence. There may be direct observational evidence. Who knows? But the prosecutor is looking for sufficient evidence to overturn the null hypothesis that the defendant is innocent. He's trying to prove guilty. And so, now, if he does a great job, then he gets a guilty verdict. And if he doesn't, or if evidence comes out that the defendant really is probably not guilty, then we don't prove innocence. We fail to reject the notion of innocence. Fail to reject. I want you to remember that phrase, because that's the one that we usually use here. So there are actually two verdicts to a hypothesis test. Now in the criminal trial, the verdict is not guilty because there's not enough evidence to reject this, or guilty, there was enough evidence. In a hypothesis test, we either fail to reject the null hypothesis because there's not enough statistical evidence to show there's a significant difference, or we do reject the null hypothesis because there's sufficient evidence to show that it's statistically different. Alright, well that's a bit to digest there. Just have to chew on that a bit. But let's continue on with the problem here.